Hey guys, welcome to another lesson. So today we continue on with the topic of vectors in the Extension 1 syllabus, specifically covering geometric proof. So if you haven't already done so, please subscribe to the channel and like the video, tell your friends. It's a free sort of service that I just like to get some information onto the internet, right? So vectors, geometric proof. So today we're going to basically continue on with some common geometric proofs, some common questions seen in past papers revolving around, I guess, two concepts. One, where it's just all about the resultant vector, where you have the sum of many vectors gives you one resultant vector. Commonly seen when you try to prove relationship of sides or magnitudes of sides or ratios of sides. And also this notion of parallel vectors in this topic. So let me show you what I'm talking about. So the first one is a very easy concept, right? So generally speaking, if you have one resultant vector, right, and it's comprised of, many smaller vectors which go head to tail to that head to tail of the original. So let's say this is like U1 vector, this is U2, U3. Then we know that the resultant vector of U is equal to the sum of all the individual vectors, right? Pretty easy concept, very commonly asked, obviously, in vector proofs, right? So that's the first piece of sort of bucketing of questions. And then the second one, parallel vectors. Sorry, parallel vectors. So to be parallel in this topic, right, in this part of the topic, you can get like, ones that are longer, right? So this is vector A and this is vector B. If one's longer than the other, that's absolutely fine. They can still be parallel. So basically, the point is that B is equal to A. Now, when you say it's equal, right now, you're saying two things. We did this in the last lesson, right? When two vectors are equal, they're parallel and equal in length. Now, we're saying we don't necessarily need equal in length, so I can introduce a sort of scalar in front of one of the vectors, which basically means that as long as you have the two vectors being equal, as a multiple of each other, it's parallel, right? One's longer than the other. Now, that's important. It sort of ties in with collinear points as well. If you had to prove that, where if you were to do this between 3 points, as long as one of the points is common and they're parallel, then it has to be collinear. So we might look at that in a later video, maybe next week, next lesson. So these are the two concepts we're going to delve into. Let's get started, right? So I've got 3 past papers that I prepared for you. So one from Sydney Girls. This question is worth, now, I think the context of the marks is actually quite important. 3 marks, right? In a test that has 70 marks in total, it's about 5%. So 5% test, 1 question, it's pretty good value. So let's dig through this. In the diagram below, we have these pieces of information. So we got this guy is A, okay, that's given, great. AC, well, that's not given in the diagram, kind of weird. Oh, maybe I'll write that in. So this one here, from here to here, that's C, and here to here. Yeah, that's A, good. Point P, let's see. Point P, AP is 1/4 of AB. Now, I'm just going to write this in green just to make sure it's 1/4. And because it's a parallelogram, good. Because basically that's C as well. So this must be 1/4 of C. I say Q over here is 2/3 of OC. Okay, so this one here is 2/3 of C. All right, cool. So that's these two pieces. Find PQ. What's PQ? Here. In terms of A and C. Okay, that's not too bad, right? Wait, did I get captured? Okay, I got it wrong right there. This is 1/3, right? Because that's 2/3. Okay. I mean, using my resultant vector, I can sort of see pink, which is what they want PQ. PQ also almost looks like it's PA, AO, OQ, right? Piece of cake. So let me draw that out again. So if I went that way for the top vector, and the pink vector that I want, right? PQ sort of looks like that right now. That is PQ. Let's label that PQ. I've got a green one coming back this way. And I've got blue one going down this way, right? So green plus blue plus green equals to pink. Now, I just got to reverse the order of this. This one here will be -1/4 C because it's going backwards. The A looks like it's negative as well. And the green one is fine as it is of 2/3 C. That's right. Let's see. PQ. Yep. So, I mean, if I was to make my teacher happy, right, I'd give the first expression to be PQ as a vector equals to PA plus AO plus OQ. Right, and then I go, well, PA is -1/4 C plus, or minus A rather, plus 2/3 of C. Now, can I gather? That's just minus A. What's 2/3 plus a quarter? So like 12, 4, 8, what's 5? 5, yeah, perfect. 5 on 12C. Minus A. They tell me that's it. That's it. 3 marks. Wow, that's good value for a Sydney Girls test. There you go. Done. How was that? So it's going to be maybe a pretty short video, but hopefully it demonstrates point if questions are going this fast. I think the later ones will take a bit longer, but first question, not too bad. Not too bad. Let's look at Hunter's Hill. Yeah. Oh, okay. This one here, a bit more involved. Let's have a look. So 2020 Hunter's Hill. In the parallelogram here, this guy is OA. Where's OA here? All right, that's OA, that's A, good. OC is also given. Right, beautiful, that's these two, done. Now let's see. X is the midpoint of AC. Okay, so it's the diagonal. So that guy there, X is the midpoint, so I'm just gonna draw that. There's X. Yeah, midpoint, okay. OCD, OCD is a straight line with the ratio K to 1. Okay. I see, now this is important. So the ratio is like, maybe I'll do it like this. Oops. Ratio K to 1. How do I do this without actually destroy my diagram? Okay, let's see. This is K and this is 1 as a ratio, right? Okay, so that's this bit. Cool, that's done, that's covered. Got it. Yep. Find OX. Ooh, we're going this way now. Okay, what's my pink one? Find OX. Yeah, in terms of A and C. All right. Now I know, don't I? Right, that's a diagonal as well of a parallelogram, right? So if that's A and that's C, then I know the pink is like the sum, right? Because it's in the middle. And then because it's a midpoint, yeah, diagonals bisect each other. So these as a length is equal. And so is the green, I guess. Then OX is just half of that pink. Okay, cool, easy. So part 1 mark, and it says fine, not proof, good, even easier. So I know, right, if you had to sort of prove it to yourself with my blue, you know, you got this guy over here, you got this guy over here, that's A, that's C. If you've put head to tail, right, you'll get this guy being the product, sorry, the sum, right? Let's just do like this. Yeah, where then I know, right, the one that goes right in the middle there, right, which is my OX, right, just be half of that. Right? So therefore, OX as a vector is half of A plus C. Pretty sweet. Yeah. OD, where is it? OD. So, okay, well, this one's a bit harder. Let's have a look. Find an expression for OD. Okay, look, the way I'm going to do it is basically if you picture OD to look like this, right? OD to look like that. It's basically like a magnification, right, of the vector OC. So where's OC? The blue OC is over here, right? So this is OC. It's just a magnification. Now, what's the magnification? I know the ratio, right, of this guy. So right now, just to be clear, this is vector C, right? So I won't write that in because I want to. The ratio here, that's K. Yeah, and then the full length one is K and what's a K plus 1, right? So the magnification factor would be K plus 1 on K, right? That would magnify from the blue to the black. So what I'm going to do is go, therefore, the vector OD equals to the vector OC, but multiplied by a scalar, right? A magnification scalar that goes in the ratio of K plus 1 on K. That would do it. That would make it larger. So therefore, I know that OC is C tilde. So that equals to, now I'll put a bracket, K plus 1 on K multiplied by C vector, piece of cake. How many marks is it on total? This is 4 marks here. So once again, a decent whack of your extension 1 paper, right? Is that okay? So for nothing too, rocket science here about that. So last piece, find XD. Okay. Let's draw this properly. That's not properly. That's as good as it can get. Yeah, find that black vector. Now, basically, they've made me found pink. They made me find, now what color did I use? I'm just going to use blue. That goes all the way from here to here. Pink, blue, black. Feels like I can use some of vectors to do it. So the black one, so for part 3, looks like there's a big black one there. There's a blue one that goes from here to here right now, and there's a pink one that goes from here to here, right? And putting the letters just for completeness, that's O, that's X, and that's G, right? So what have I found, guys? So from the top one here, this guy here, OD, is K plus 1 on K times C. What else do I know? That the pink one, what was it? Half A plus C. Yeah, and they've given me this black expression to be 3C minus half A, right? Now, I'm hoping that when I connect them all, I can find the value of K. That's hope. Now, let's see which one's head to tail. So it looks like blue equals to pink plus black, right? You can see blue, pink plus black. So let's set that up. So in this here, your teacher will be very happy to hear that you know that OD equals to OX plus XD, right? So plug it in, right? Blue is OD, so. And remember, I'm trying to see if I can compare things to make K the subject, right? OX, what's OX? Half. All right, I need A's to cancel out. Does A's cancel out? Yes, it does. Beautiful. Why? Because I know I'm going to be comparing the numbers in front of C. So check this out. Plus XD. Yeah, it's always good to know where you're going, all right? Look at this. When you expand this, so ignore the right-hand side or left-hand side for now. Expand the right. Yeah, half A plus half C plus 3C minus half A. Yes. And then this guy goes away. Yes, 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 yes. Yeah. And then you have, therefore, what do I have here? Hey guys, I'm going to do 2 things, right? See this? I'm going to be big brain and split that. Oh, is it even what? Nah. Yes, big brain. Let's do it. Yeah, let's big brain that. I know this guy is going to be 1 plus 1 on k, right? Yep, so therefore 1 plus 1 on k c equals to now 3, what's that, 3.5, 7 on 2 c. Now, since the a's go away and they're both equal to c, then I know that whatever's in front of c are equal, right? So when you set these two guys to be equal, you get therefore 1 plus 1 on k equals to 7 on 2. I need a little bit more space. Let's go this. So a bit more. Yes, yes, yes. Here we go. Oop, too far. And then let's clean up this 1 on k equals to, what's that, 5 on 2. Therefore, reciprocal that. K equals to 2 on 5. How is that? Pretty sweet. Right, I like that question. It was nice, right? 4 marks, a bit more intense than the last one, but no, not too bad, hopefully, just by head and tails. Yeah, guys, I've got one more question from North Sydney boys. Yeah, this one here, maybe a bit more intense, right? Let's have a look. All right, on your diagram below, I got, okay, let's do this again. AD was that over here, got that to be A, very small. Let's replace that. That's this guy, done. All right. Got DB, this guy, to B, 3B minus A. Great. All right, that's this guy. AC and AB are straight lines, yeah, thanks. And given ratio AD, dy 1 to 1 to 1, okay. So ratio wise, that guy there is 1. Oh, I should have run over that. So maybe I'll just go 1. It's always hard to show ratios on the diagram. 1 to 1 to 1. You know what? If it's 1 to 1 to 1, don't worry about the ratio. They're just all equal, right? These got all equal, which basically means that that's A, and that's A as well, right? That's really what it's trying to tell you. Yeah. And then AX. Now this one is should AXB. Okay, I need to show ratio there. This guy to this guy here. Okay, that ratio is 2 to 1. Okay, cool. What am I doing? Show that XY show that XY is parallel to BC. Okay, there it is, parallel. So just to be absolutely clear here, which is what I wrote at the start of this lesson, this guy's basically saying, can you please show that the vector XY, and maybe I'll do BC first because it's longer. So I'll go BC is a multiple, some sort of scalar multiplied with XY, right? Hopefully I could do that. That's really what it's asking me to prove, right? Yeah, so translate that, that's your game now. Doesn't make sense then. If you can find an expression for both of the pinks in terms of A and B, you should hopefully get, big pink equals to 2 times small pink or something like that. That'll be sweet. So your aim right now is basically to do that. Now, what do we know? Right, I need to find, using the first triangle over here with A and 3B minus A, I can find an expression for the big green, and then I'll carve it up into the ratio of 2 and 1 so that I can get expressions for the pink. Let's do that, right? So let's carve this all up where I got, so using the triangle ADB first. So I got one that looks like that, one that looks like that, and I've got a big green one that looks like the resultant between these two. Is that right? Boom, boom. Yes, yes. So this guy's A. This guy's 3B minus A. Great. And let me just label it for working out purposes. Right. So therefore, I've got green, which is AB, equals to, so AD plus B, DB, which equals to A plus 3B minus A. Oh, look at that. A's go away. 3B only, right? So therefore, AB as a vector, the green vector, right, equals that. I am going to just write that here, 3B, nice. That makes sense. Now, if that's 3B and the ratio was 2 to 1, then that's telling me diagrammatically, this guy here is vector of 2B and this is B, right? Perfect. Now, I got one triangle to get me my small pink, one triangle to get me my big pink, and I'm there, right? Pretty easy. Yeah, actually, I talked it up too much. This question is actually not too bad once you realize, once you figure out that to prove parallel vectors, that's all you need, a multiple of each other, right? So I've got this guy, got this guy, I've got pink as well, going down. Yeah, all right, so let's see. I'm going to go head to tails on this, right? So I want pink to remain as the final thing that I want to do. So I'm going to reverse, I'm going to be smart, reverse the green, right? Let's go backwards on this, right? So then it's all head to tails, right? It's all head to tails. So green plus blue equals pink, perfect. So there's A, now what's green again? Green is 2B, or negative 2B now, right? Because I'm going backwards. And then this is blue, that's A. So therefore I can conclude, oh, I don't even need it, therefore I'm just starting the sentence. XY as a vector equals to minus, oh, wait. This A on the bottom, it's actually two lots of A's, right? Yeah, 2 lots of A. So because X, Y is here, D's over here, right? Yep, cool. So it's like minus 2B. Okay, let's see. Minus 2B plus 2A. Now, if I factorize a 2 out, I get 2, maybe put the positive one first, A minus B. Yeah? So I'm hoping that if I can get the big vector of BC, the pink one, to be some other multiple of A minus B, I'm sweet, right? So let's see, zoom out. Come up here. Draw exactly the same one. It's actually just a bit larger, right? Got a bit more. Now, once again, I'll reverse the order of the green, right, to get the expression for the pink to be resultant, right? Yeah, so this one here is A, B, C, and I know the green going backwards was 3B going up, so negative 3B going down, and I know because it's 3 lots of A on the bottom of this 3, look at that, right? It's clearly a ratio. So I can see that BC as a vector equals to minus 3B plus 3A. Factorize the 3 out. Sorry, I think I was a bit naughty. You know what? I should really put the line of BC equals to. I didn't do that first. Let's just move on. Yeah, move on. I was going to say BC equals to BA plus AC. Let's move on. I'm sure your teacher will forgive you. Yeah, guys, look at that. They're both multiples, right? So I can say therefore. Yeah. Therefore, BC equals to, let's see, how do I, oh, okay, I'll play it like this, right? I'll play it like this, right? Yeah, I was going to do something, and then I realized it's harder to explain if I do. I'm gonna, for both of these, make the vector, make this guy the subject, right? Therefore, A minus B equals to XY on 2. Now be A minus B equals to BC on 3, right? Since they're both equal to A minus B, therefore XY on 2 equals to BC on 3. Make BC the subject because it's bigger, equals to 3 on 2 XY. Done. And therefore, because it's a scalar multiple of I can say BC Now, do they want me to write vector or just the points? Just the points, right? Yep. So BC is parallel to XY. Yeah, I mean, not too bad, but the marks are decent, nice. 3 marks, 3 marks for this one, 4 marks for the previous, and 5 to 6, 7% in tests, guys. Very good value. Hope that was useful. Next video, let's do a few harder questions with vectors, vector proofs. Hope you like the video. Share with your friends, and I'll see you in the next one. See you later.